We are now going to look at thermodynamic processes, or simply processes in short, because everything that we do is thermodynamics. In fact, process is a nomenclature which is nothing but a short form. So it is equivalent to a change of state. And since state belongs to a system, a thermodynamic system, a process is always executed by a system. So a thermodynamic process is nothing but the change in the state of a thermodynamic system, and hence a process is always executed by a thermodynamic system. And because a change is involved, the minimal thing which is required for a process is you must have a system properly defined, and you must have an initial state and a final state. In a visual way, let us say that we have a system, and let me simplify its state space in a two-dimensional way. If you are comfortable, you may write pressure and volume, or you may write temperature and mass, whatever. This is just for illustration. Or you could simply write x and y. X and y could be any two properties. So the depiction of a process is initial state, final state. This is the minimal representation of a process. You must have a system, you must have an initial state, and you must have a final state. Now initial state and final states are big words, so quite often we will use symbols like 1 and 2 for initial and final states, or sometimes I for initial, F for final. We will mark those things down. And remember that since a change of state is involved, since process means a change of state, and since a change of state is represented by a property, a process involves a change in at least one property.